Welcome everyone to your virtual academic orientation tour. My name's Nikki and I'll be your virtual tour guide today. I graduated from the Aerospace Engineering program here at Carleton a few years ago. I now work for the Faculty of Engineering and Design's outreach team. In this tour, we'll be looking at some important spaces on campus, including some labs you can expect to see as you progress through your degree. Our tour begins at the Minto Center. From the main atrium, we will be heading down into a chemistry lab that is primarily used by environmental engineering students. Next, we'll be visiting the large testing facility on the main floor and the Engineering Academic Support Office. On the 5th floor, we will be viewing the Elsie McGill Learning Center. And finally, on the 6th floor, we'll be visiting the Biomedical Engineering Lab. We're now in front of the Minto Case building. This is part of the main engineering building on campus and is connected to the McKinsey building, which you'll see later on. Let's head inside. In the main lobby area, if you look to your right, you can see the entrance to one of our largest lecture rooms, Bell Theatre. Remember this location, as a lot of first-year students always struggle to find this theatre. We'll now be moving downstairs to our environmental engineering lab. We're now in the basement of the Minto building. This lab is essentially a chemistry lab for environmental engineering students to understand the chemical, biological, and physical processes involved in cleaning air, water, and soil. Students will take river water and separate its contaminants using chemical physical processes, or treatment using UV light. Wastewater treatment is done by using microorganisms to break down the contaminants in the wastewater. The materials that settle out form a sludge that can be degraded anaerobically to produce methane and energy. Air quality is measured and analyzed using an air sample from the roof of this building. Fourth-year projects include designing systems to clean air and water, cleaning up contaminated sites, gas stations, LeBreton Flats, evaluating waste management alternatives and waste to energy, designing systems to reduce greenhouse gases, and improving air quality and conserving water. Let's head upstairs. We're back on the main floor. This is the John Adeline Lab. This lab is used by 2nd, 3rd, and 4th year architectural conservation and sustainability engineering students, environmental engineering students, and civil engineering students. The test facility is 11 meters high and has 3,000 square feet of floor space. If you look up, you'll see a crane used to move heavy equipment around the room. This room is also equipped with a strong floor that is 1 meter thick. If you look down, you'll see circular discs that can be removed from the floor. There are approximately 600 holes in the floor to allow us to test different structures. Test beams can be secured to the floor through these openings. The foundation of this area is also separate from the rest of the building around us, so test vibrations do not impact the structure or disturb people working. MTS loading machines can perform compression and elongation analysis to samples rather than an entire structure at variable speeds, as stresses produce different results at different speeds. Tensile compressive and cyclic load testing is done using hydraulics wired to an Ethernet analysis, which can simulate year-long experiments in shorter times. Students will also have the opportunity to learn how to use surveying equipment and will make their own concrete beams to be used for testing shear strength. You've probably been receiving a lot of emails from our Engineering Academic Support Office, or the ASO for short. The ASO team is here to assist engineering students with course selection, registration, learning resources, and extra support. They are available to help you from your first year all the way through to graduation. All ASO services are currently being delivered remotely. We'll now be heading to the 5th floor of the Minto Case building. Here we have the Elsie McGill Learning Center, or as I'll refer to it as, the Elsie Center. We're focused on ensuring that students have an understanding and comprehension of their engineering studies, and we're here to provide some academic support to help you achieve your learning goals. The Elsie Center operates using a peer tutoring model to offer academic support to first-year engineering students. Peer tutors, who we call scholars, are hired and trained to assist you in your learning. Whether you have a quick question, you just want to review a solution, or you want an explanation of some content that was covered in your classes, our engineering scholars are here to help you with those. And while the Elsie McGill Center won't be delivering in-person services this fall, they will be available through our new online tutoring platform. We are now on the 6th floor of the Minto Case building. This lab is mainly used for 3rd and 4th year biomedical electrical engineering students. Here, students use wireless biosignal amplifiers and electrodes to collect EMG and ECG signals and then write software to clean, analyze, and visualize the data. Now that you've had a good look inside the Minto Case building, we'll be moving on towards the next building of our tour, the Mackenzie building. The Mackenzie Building contains a range of facilities that support all of the engineering disciplines here at Carleton. First, we will be heading into the Solid Mechanics Lab on the main floor, and then we will be visiting the Water Channel Lab, a Thermodynamics Lab, and the machine shop. On the third floor, we will be visiting the office space for the Carleton Student Engineering Society. And on the fourth floor, we will be viewing the Mechatronics Lab, as well as the SCE workspace. Let's head over to our first lab. Both second and third year students in the Department of Mechanical and Aerospace Engineering will use this lab to understand the fundamentals of solid mechanics. This is the Solid Mechanics Lab. In using the blue rig scene, students are able to analyze the deflection and strain in different cross-sectional area beams by adding weight to one end of the beam test section. Then, using this experimental data, students will apply the theory they've learned in class in order to determine the minimum and maximum stresses, elongation, and yield strength of the material. These labs are typically done with teaching assistants and students in groups of 2 to 4. Lab reports must be submitted at the end of the 3-hour lab period. This requires students to practice time management and preparation. It's also important to note that our laboratory technologists are always available to help with curriculum, lab assignments, and fourth-year project work. Now, let's walk over to the second block of the Mackenzie Building. This is the Water Channel Lab. Again, this lab is used by students in both the Department of Civil and Environmental Engineering and the Department of Mechanical and Aerospace Engineering. Second, third, and fourth year students use this lab to understand aspects of aerodynamics using fluid dynamics. This channel is also used to study high angle of attack flows dominated by flow separation and rotary wing wake analysis. Used as dye water channel for these tests allow for accurate testing of small-scale models while producing excellent flow visualization, which helps researchers understand airflow behavior. We're now in the Thermodynamics Lab. This lab is used by both students in the Civil and Environmental Engineering Department and the Mechanical and Aerospace Department. Both second year and third year students use this lab to understand the fundamentals of thermodynamics and heat transfer by analyzing gasoline engines, diesel engines, gas calorimetry, and a carrier air conditioning system. These engine tests are done to determine power, emissions, and energy efficiency. Along this wall, you'll also see a mini cooling tower experiment, which is used to understand how superheated water with debris is transformed to clean cold water. 2 teaching assistants will assist groups of 2 to 4 students to complete the lab within a 3-hour lab period. Let's move on. We're now in the Department of Mechanical and Aerospace Engineering's machine shop. This is where both the building and manufacturing takes place for all 13 of the department's capstone projects. Students have the opportunity to learn how to use the equipment found in this lab throughout their 3rd and 4th years. This space contains computer numerical control machines, or CNCs, drill presses, lathes, a welding station, a metal 3D printer, and a tool shed. CNC machines process pieces of solid material, wood, metal, or plastic, to meet specifications provided by a coded program. Lathes produce similar objects as CNC machines, however the solid material is rotated on an axis and is manipulated without the use of a coded program. Therefore, the machinist analyzes the engineering drawing and operates the lathe to produce the part. The toolshed contains all of the tools you'd ever need to complete a project, and they are given out on a rental basis, free to use. Another excellent aspect of this space is the interaction between students and the technologists. Students can sit down with the technologist to discuss the mistakes they've made in their engineering drawings, while learning how to professionally produce drawings and correctly communicate their ideas. We're now on the third floor in the third block of the Mackenzie Building. You are currently in the office space for the Carleton Student Engineering Society, or CSES for short. All students are members of CSES and have access to many of their services like textbook trades, networking nights, social events, and much more. The unique thing about this floor and block is that it's dedicated to our engineering clubs and societies. There's stream-specific societies like CMAS, which is the Carleton Mechanical and Aerospace Society, CSOC, the Systems and Computer Engineering Society, and many more. You'll also find clubs like Engineers Without Borders, EWB for short, See You in Space, They Build a Cool Rocket Every Year, and many more. It's a great way to get involved and gain skills outside of your engineering program. This area is also home to Leo's Lounge, which is completely volunteer run. It's the cheapest spot on campus to grab a coffee or snack before class, or if you're just looking to hang out, play some games, and make new friends. We'll now be heading up to the fourth floor. This lab introduces all first-year engineering students to electrical circuits and mechatronics. Students are introduced to DC and AC circuit behavior and electrical measurements using waveforms, generators, oscilloscopes, and multimeters. Students are introduced to digital systems based on the Raspberry Pi single-board computer. Python coding is used to enable sensor measurements as well as control of displays and actuators through the general-purpose input-output GPIO pins. Students work in multidisciplinary groups to complete a mechatronics project. This fall, lab stations will be remotely accessed from outside the university. Students are able to control the generator and oscilloscope or remotely program the Raspberry Pi, and observe the results through a webcam. Teaching assistants will be available in the lab and by phone or Zoom to help students through the experiments. This is our last stop in the Mackenzie Building. It's a collaborative workspace for students in the Systems and Computer Engineering department. It can be used for meetings, experiments, presentations, and much more. It's also a makerspace available for student use, equipped with 3D printers, soldering stations, spare parts, and test equipment like oscilloscopes. Students are encouraged to apply what they learn through student clubs and independent projects. The space is often used by student groups such as the Robotics Club and the Stay Late and Make, or SLAM Club. The next building we are touring is the Architecture Building. We will pass through a bridge that connects the Mackenzie Building to the Architecture Building and continue down the hall into the first-year studio on the fourth floor. From there, we will head downstairs into the pit. Then we'll take a look at the wood shop and the metal shop. The Mackenzie Building and the Architecture Building are connected by this pathway, which also doubles as a cool study spot. The Architecture Building houses both undergraduate and graduate programs, built in 1971 specifically for architecture. This building was inspired by Rome. It has a grid-like structure with a north-south and east-west intersection hub. The building is famous around the world for its city and community feel. The main floor of this building consists of lecture halls, classrooms, and other shared spaces. The third floor consists of offices and fourth floor studios. Every year, you get your own studio workspace. There's one instructor to 15 students. Studio is a really tight-knit community. It is an important learning and social space. In the first year, you tackle small projects while getting progressively larger and more complex as you continue your studies. Take a few seconds to look around the room. We'll now be heading to the main floor. Right off the main street, the pit is a multi-purpose area. It can sit up to 100 people and is used for lectures, meetings, galleries, and reviews. Reviews are when students present their work and get feedback from faculty, professors, and their fellow students. We're now going to see some shop spaces for students in both the architecture and industrial design programs. This is the Wood Shop. It's one of the best and largest shop facilities in a School of Architecture in Canada. It's fully staffed and supervised by expert technicians. It's what makes the Israeli School of Architecture and Urbanism so renowned. All first-year students must attend and pass a woodshop orientation in order to use the facility. It consists of 4 main spaces: the woodshop, metal bending area, welding area, and assembly room, a space where you can build large-scale models and objects. The Digital Fabrication Lab and Soft Lab are located in room 214 of the Architecture Building. The Soft Lab is equipped with sewing machines, both heavy and light duty, layout tables, mannequins, and ironing boards and irons. This space can be used for any work related to soft materials. The Digital Fabrication area also contains the print shop and a loan pool where you can borrow equipment from the fabrication facilities. You also have access to CNC machines, 3D printers, and laser cutters here. This area also contains the metal shop. This is the metal bending area of the shop. As you can see, this room contains a lot of tools and different machines for students to use on their projects. Students can choose to work with metal for their models or prototypes. This area also has specialized equipment to manipulate all different types of metals. Let's move on. On the exterior of the Architecture Building. If you look to your left, you'll see the University Center. If you look to your right, you'll see the next building that we're going to be heading into, the Canal Building. Take a moment and look around. The Canal Building houses many classrooms, labs, and lecture halls for Fed students. We'll be entering into the main atrium and then heading up to the 3rd floor to visit the Hydro Ottawa lab. Next, we will move up to the 5th floor to visit the Texas Instruments lab. And finally, on the 7th floor, we will be visiting the biomedical lab. We're now in the Canal Building lobby. This floor is home to Second Cup, lecture rooms, computer labs, and some lab spaces. We'll be heading to the 3rd floor to see our first lab space, the Hydro Ottawa lab. This is the Hydro Ottawa Lab for Smart Grid Technology. This lab is primarily used for students in the Sustainable and Renewable Energy Engineering courses. Students complete experiments on key power topics including circuits such as buck and boost controllers, three-phase systems, rotating machines and motor control, and loads and their effect on power quality. Students are introduced to industry-standard ETAP power system analysis software, enabling them to investigate all aspects of power generation, transmission, and distribution. This fall, lab stations will be remotely accessed from outside the university. Test circuits will be pre-wired by teaching assistants. Students are able to control the lab volt control and measurement modules to complete experiments. We will now be moving to the 5th floor. This is the Texas Instruments Lab for students in the Systems and Computer Engineering department. It is used by 3rd and 4th year students in order to understand the applications of digital signal processing. Students will program using MATLAB and develop filter models in Simulink. Each workstation has its own dedicated Texas Instruments test equipment so that students can deploy their digital filters on actual hardware systems. We're now headed to the 7th floor of the Canal Building. This lab is used by 3rd and 4th year biomedical and mechanical engineering students. It is equipped with an MTS servo hydraulics load frame, OptiTrack system, jolt press, porcine bones, and biomedical tools, such as hip plants, screws, and rods. 8 students will work in groups of 4 with 1 teaching assistant to test the effectiveness of biomedical implants. Students will have the opportunity to clean porcine bones, test them under load and tension, break the bones, implant the biomedical devices, and test them again. We'll now be heading over to the final building of our tour, the Israeli Pavilion. The Israeli Pavilion houses many labs, workrooms, and studio spaces for Fed students. We will be starting on the first level and visiting a large computer lab area. Then we will head up to the second floor where we will visit some specialized studio and maker spaces. Finally, we will end up at the fourth floor where we will see some other studio spaces for industrial design students. This is one of the computer lab spaces for students in the Bachelor of Information and Technology. This lab space contains over 100 new computers for first and second year students. Labs are usually open to all BIT students to use outside of scheduled class time. The computers are equipped with the programs you'll need for any of your required courses. We're now in the state-of-the-art motion capture lab. This lab is used by undergraduate and graduate students in the BIT program. It is fully equipped with cameras, lights, green screens, filming equipment, and dolly tracks. Students will use this in classes such as the IMD animation course. This lab is one of the largest motion capture labs available to undergraduate students in Ontario. This is the Anthony Whitehead Makerspace. The Makerspace contains an industry-grade laser cutter, 3D printers, resin printers, soldering stations, and a sewing machine. This lab is bookable and students can use this space to work on projects and gain additional hands-on experience. We're now in the recording studio. This is a bookable space that students will use for upper year courses like animation, And students will gain an understanding of how to use professional equipment. We're now on the 4th floor of the Israeli Pavilion. This is an industrial design studio space. The studio space has various rooms depending on your level of study and a beautiful view of the Rideau Canal. This space allows students to work on projects or simply come in to study. It is equipped with a storage area where students are assigned bin spaces so they can store their materials. Students can also use the Maker Lab, which has 3D printers, laser cutters, and workbenches to allow for additional design work. As you pan around, you will see multiple rooms that are for design studios and classes depending on your year level. Another unique feature of this space, it is equipped with its own gallery space. Here, students can present their work to faculty and members of the community for feedback. Additionally, students are able to book lab time with lab technicians in the Mackenzie and Architecture buildings. You will learn how to use specialized equipment that you saw earlier in the Architecture building labs. Thank you all for joining me today on this virtual tour. I hope you were able to see some of the lab spaces you'll be able to use when you join us here on campus as you progress through your upper years. I'll be sticking around to answer any questions you may have about the spaces you've seen today. Please feel free to use the chat feature in the YouTube live session, and I'll be answering those questions there. Thank you, and enjoy the rest of your academic orientation day.